Good morning, all. Following to the previous lecture on case study in mechatronic design, a 3D printer, we are going to look into the following steps. Okay, so conceptual design is a main significant step in the generalized mechatronic design process, which includes three steps: concepts generation, concept screening, and concept scoring. Okay, so this is the first concept which I am considering. So, which is a stereolithography concept. So you'd have seen this concept in the video which I have shared. Okay. So the main components, as you can see in the slide, the main components are a laser source, a resin tank, UV curable resin. So this is the component. This is the material. Resin is the material which I am considering for this concept. A movable build platform, X-ray scanning mirror, and an elevator. Okay, so the elevator is lift to this as, so this is the elevator. So this is the resin material. So resin material. So when this laser hits on this resin material, the part of the resin material which will get hardened. Okay, again the laser is shifted to this part and this will be hardened. So the laser is being adjusted by the this X-ray scanning mirror, so that after a particular time the resin material over this part will get hardened. Okay, then the elevator is brought down, and then the second layer is being hardened. So such process is used in this concept, and this is an inverted process of a stereolithography printing method. Okay, so this is a 3D printer which is already available in this market, as I have said, which is an inverted. So this is a print bed. So this is the print bed, and the component will be printed in an inverted fashion. So this is the resin material. Okay, so this is the resin material, and it will be component will be printed inverted. Okay, so UV rays or laser source will be bombarding or will be given from this direction. Okay, so as you can see, the components major components is a laser source, resin tank. This is the resin tank. Okay, then UV curable resin, then print bed. So this is the print bed. So this is the print bed. Okay, X-ray scanning mirror. So in this case, here you'll be having X-ray scanning mirror. Okay, then servo motors, then embedded softwares. Specification, this is specification. The weight is 2700 grams or 2.7 kilograms. So build volume. So as you can see, this is the build volume of this 3D printer, but our need is like 100 mm cross 100 mm cross 100 mm. So this is like it's not satisfying the need. So uh, so this 3D printer is in a the is in a question to use to consider for the design or not. Okay, so the approximate cost is about 37,000 rupees, but cost doesn't is not a significant matter in this design, because we are not building in a low cost 3D printer, right? Okay, so this is the second concept which I am considering, which is a fused modeling and deposition modeling technique. So so this is an Creality Enter 3 3D printer which is already available in the market. So I am considering this concept as the second concept. So this is the print bed. So built and pulley mechanism. You can see built and pulley mechanism over here. In the first, in the previous lecture, I have shown this 3D printer as to give an introduction to the 3D printer, right? So considering the basis of knowledge which I have given in the first lecture. I'm directly going into the concept. Okay, so belt and pulley mechanism. So this is a belt and pulley mechanism. So extruder, this is extruder. Then stepper motors, you have stepper motors over here. This is a stepper motor, this is stepper motor, and you have stepper motor at the behind. Okay, then limit switches, you have limit switches. Then Mega 1284P controller. Then embedded software. Okay, so these are the side views and isometric view of the same 3D printer, in which you can see clearly um, the LCD display and the power plugs. Okay, this motor at the behind. Okay, right. These are the specifications of the printer. So the weight is around 1400 grams. So build volume is uh, again 220, 220, 250, which is more which is far more than our need. So it's well and good. Resolution is 100 microns. Then nozzle type is MK8 extruder Bowden type. Then nozzle size is zero point 0.4 mm, which is these are this doesn't matter in our design, but the resolution and build volume and portable should be portable. These are the main points of our design, right? Okay. So PLA material is used. Embedded software Cura is used. Then the approximate cost is 17,000. Concept generation number. Concept number 3. So this is a more sophisticated concept which is already available in the market, which is also based on fused deposition modeling technique. And you can see you are having a heat bed, and DC motors, extruders. Extruders, you will have having extruder over here. Okay. Then stepper motors. So basically, DC motors will be considered as a substitute for stepper motors in case of an emergency. If the stepper motors, expired stepper motors are uh, not working, you can use DC motors. Okay. So in most of the part list in various 3D printers, you will not be available, and they will not give this DC motors. Okay, so controller, you can use proprietary controller, touch screen enabled. It's a cloud print. You can print from the cloud. Built-in filament box will be having a filament box behind of this. Then LCD display. This is the LCD display. Embedded software. Okay, so this is name of this 3D printer, Flash for Finder. Okay. So these are the specifications. So weight is 2,800 grams. Build volume is also satisfying. Okay, resolution is to maximum to 500 microns, which is a good resolution. Nozzle type is proprietary. Nozzle size and PLA. Okay, it is far more costlier, 78,100. Okay, than the two concepts which we consider. So this is concept screening and concept scoring. So actually, the three concepts are tabulated. So the needs are being highlighted. So it's a specific material. So this uses resin material, first concept. This using PLA. This is using PLA. So that is satisfying. So weight is around 2,700. So this is 1,400. So this is 2,800 grams. So this is of high weight, which is not portable. This is least weight. So this is portable. Then again, portable, yes, yes, but this is not portable. The highest weight is considered to be not portable. Okay. So resolution. So this has a resolution. This has resolution of 100 microns. This has resolution of 100 to 500 microns. Build volume. This does not have the build volume of 100 of sorry 10 centimeter in the x-axis. We have seen that. So this has a build volume. This is the build volume. So these are the requirements of our need. But when both concepts or more than one concepts having the same scoring, you can consider some more inputs which depends on the designer. But as far as these parameters does not disturb the output of the print of the design process, you can use that. Okay, uses FDM or ST method. So this is FDM, fused deposit modeling or stereolithographic method. Yes, yes, it uses. This is also, this concept 3 also uses. So this uses stereolithography method. This uses a fused deposition modeling. This uses fused deposition modeling. Okay. So cost is medium, cost is less, cost is high. Okay. Then the score, you have the maximum score for concept number 2, which satisfies all our needs. So concept number 2 is chosen for our design. Okay. This is the sensor selection step. So sensor selection is basically mm, depends on the operating range, the bandwidth, the power supply of the sensor, the operating frequency, then the payload. Okay, and the most important factor, which is considered to be mechatronic uh, uh, for mechatronic design, is the range. Okay, so as far as the other things are concerned, you can at least put some drivers or circuits to compensate the other parameters, but the range is an important factor. So the input parameters for or um, exactly, the input parameters for this 3D printer is basically a STL file which will be provided to the controller of the 3D printer. Okay, on the based on the STL file, the printing process will continue, right? Okay, but a main sensing element which is considered to be a 3D printer is a temperature sensor. So the heat bed should be in a particular temperature to start the printing process, and then the proximity sensor. So the extruder should be nearer or should be available to print on the print bed, right? So that will be measured by the proximity sensor. So to detect the XYZ at end positions, mechanical limit switches are used. Okay, these are the sensors which is used in the 3D printer. So these are the limit switches. Uh, so this is a type of limit switch which is already available in the market. Around each one costs around 120 rupees. So this is particularly used for 3D printers. Okay, right. So thermistor, this is the thermistor which is used in 3D printer. So it's a 100K ohm NTC thermistors. Okay. So actuator selection. So we'll stop with this. We will continue with the actuator selection in the next lecture. Thank you. Thanks for watching.